All right. Hello, everybody. Thank you so much for joining today's session. This is an introduction to product management. I am so glad you're here. So excited to talk through all this material. It's going to be about a 2.5 hour session. So this is a full online course. In case you didn't know, we're going from now 12 p.m. Eastern Time till 2:30 p.m. Eastern Time. It's about 2 hours of lesson material and half an hour for questions that we're going to intersperse throughout. So get your questions ready. Anything you're curious about product management, or if something comes up along the way, uh, always happy to talk through that. So yeah, let's jump right in. Here we are. Welcome to Processing Product. You are at the beginning of a journey. You arrived here because you're curious. You know you like making things, you know technology can help you build cool stuff that people find fun and useful, and you want to know how all this adds up to a successful career in tech. That's what we're going to talk about in this course. I'm personally very excited you're here because I think product management is one of the most fun and adaptive roles you can play in our current economic system. In practical terms, product managers sit at the nexus between business leadership, which is how decisions are made, engineering, which is how things are built, and user experience, which is how people interact with what gets built. Product managers are generalists, translating between the needs and language of different teams across a company or organization. And in this course, we'll talk about practical skills that you'll need on a day to day basis to be a great product manager and eventually a product leader. The future of tech is incredibly unpredictable. How will AI affect jobs in journalism and media and any job, honestly? Which programming language is going to be in fashion 5 years from now? Is virtual reality or augmented reality a better bet than web or mobile apps? How many people will actually put a computer chip in their brain? That is a real thing. Literally, no one knows the answer to these questions, but the techniques of product management apply to all of these different technologies. We're all players in the money game, and it's up to us to find work and create work that is meaningful and hopefully even inspiring. Product management is one path I've found through the maze that I think is a fruitful one. So let this course serve as an entrance, a threshold that you can cross into new possibilities for your life, for your career, and for the communities you will serve through the work you do. So let's get started with Product 101. All right, so yeah, hi everybody. Thanks for joining this Product 101 course. To start things off, I'm going to attempt to answer the deceptively simple question: what the heck is product management? So that's going to be the first chapter. There are three main chapters that we'll talk about today. Uh, in this chapter, chapter one, I'll talk about three metaphors that kind of explain product management and give a better sense for how it fits within things. The product triangle is another example of that. And then product frameworks, sort of different ways of doing the product work that you'll do on a day to day basis. Chapter two, so chapter one's about half an hour. Chapter two, another half hour. It's let's get practical. So we're going to talk about listening to people, organizing feedback, prioritizing, and writing specs. These are sort of the four primary activities you're going to engage in day to day as a product manager. And then chapter three is really kind of the longest section. It's going to be about an hour. This is an intro to everything else. So we're going to talk about code. We're going to talk about design, UX design, which is different, user experience focus, and then data analysis and project management. So this will be sort of like a brief intro to all of those different things, and you'll see how product management kind of connects to them all. All right, so what the heck is product management? If you work in tech or follow tech news, you've probably heard reference to a VP of product, head of product, director of product management, senior product manager. You may have wondered what exactly a product manager does. In simple terms, a product manager works within a tech company or team, learning what end users want from a product, understanding where the organization's business leaders are trying to make an impact, and collaborating with engineers to specify exactly what to build and how. To better understand why this role is necessary, let's dig into a few mental models that explain the product manager role. So a few different ways of thinking about it. Product manager is a translator. Product manager is a scout. I'll say more about that. And a product manager is a navigator. So let's explore these one by one. A product manager is a translator. Code is literally a different language, a machine language, but a language nonetheless. If you've ever talked to somebody in sales or marketing, you know that jargon can pile on jargon until someone is essentially speaking in a foreign language. And then there's the realm of everyday conversation, where roughly everyone has common ground without specialized terminology. A product manager is fluent or proficient in many of these and other cultural contexts. They can understand that cost per click is an attempt to gauge the value of interactions that lead to conversions. They can comprehend that if too many JavaScript dependencies are out of date, then bugs will proliferate throughout the codebase. And they can understand the psychology of a user who just wants to find interesting collectible items without needing to do complex searching, filtering, and sorting. Product people are generalists. They can code switch, understand the language and jargon that professionals use in different contexts, and help everyone better communicate and collaborate. The product manager plays the role of the translator between these different vocabularies so that a clear definition of what should be built gets written down in a language that developers will understand, that will satisfy the needs of the business, and will make a delightful experience for the user. So that's kind of the translator metaphor. A product manager is also a scout. In her 2021 book, The Scout Mindset, Julia Galef describes the default mindset of human beings as that of a soldier, always wanting to defend our ideas against attack. She proposes an alternative mindset that we should all aspire to. She says, I call it Scout Mindset, the motivation to see things as they are, not as you wish they were. Scout Mindset is what allows you to recognize when you are wrong, to seek out your blind spots, and to test your assumptions and change course. Scouts are lookouts. They run ahead, survey the terrain, track the movements of other nearby entities, seek to understand the motivations and goals of friend and foe alike. Product managers are not content with simply soldiering forward to tackle only those problems that are directly in front of them. They know that beyond the sightline of the hills, there may be another challenge that will outflank their companions. It's necessary to have as much information as possible before making a decision. At the heart of things, product managers are doing research, gathering intelligence, assessing evidence, and connecting as many data points as possible in order to make an informed decision on strategy. And just like culture eats strategy for breakfast, it is the mindset of scouting, of seeking to understand, of always learning. This, more than any specific plan, is what leads to delivering successful product experiences. So the third and last metaphor here, a product manager is a navigator. This is a nautical metaphor. Any company or organization can kind of be seen as the journey of a ship at sea. The mission and vision are what bring the crew together to set sail towards some destination. The captain is the CEO or the president or the executive director, whatever name is given to the primary person in charge. We could go through every traditional role on a sailing vessel and draw parallels. The quartermaster is the head of HR, the boatswain is on the operations team, the carpenter is a software engineer. But for our purposes, we'll focus on the role of a navigator. It is the navigator's job to chart a course across the treacherous seas and toward the eventual destination. The maps will provide a rough guide, but are probably out of date. The stars will provide clarity of direction, but not of what lies ahead in that direction. The navigator takes all available data points and advises the captain on what the next move should be. They're not calling the shots, they're not deciding the destination or making rousing speeches necessarily, but they're making sure that the ship makes it to the destination and that the journey has the greatest possible chance of success. So, product managers are navigators. These three metaphors articulate different aspects of the role of product management. Now let's talk a little more about why a product manager is an essential piece of the puzzle in a company. We're going to use a visual aid called the product triangle, and we're going to do a bit of time travel back to ancient Greece. So, the product triangle. Now that we've got an overview of what product manager is, let's get into the specifics of the work that product managers do. When I first got into product management, I began to understand my role as being that of a translator, sitting in the center of a triangle that connects three key groups of stakeholders: engineering, business, and users. Imagine my surprise when I sketched this out on a piece of paper, and then soon after found that Daniel Schmidt had already created some beautiful diagrams of exactly this same concept. A nice little example of multiple discovery. We can think of it in this way. You've got a group of people. They use various tools to accomplish their goals and their tasks. But they have several things they wish could be easier for them. These are the users, and in product work, we refer to those frustrations as pain points. Let's use the example of a guild of blacksmiths in Athens. Maybe they find themselves with aches and pains from hammering and hammering all day. Then someone comes along and they've got a technological solution to the problem. An engineer, Daedalus, builds them a machine that will hammer with greater force than their arms could ever muster and with steady, predictable, untiring precision. Ajax immediately wants the machine and barters for it by using it to make Daedalus the finest sword in the whole region. And now that Ajax has this power hammer, Bellerophon and Caeneus want one too. Daedalus doesn't have another machine ready yet and isn't sure where the materials for it would come from. So he leaves Bellerophon and Caeneus to debate each other while he works on some improvements for the next model of the power hammer. Electra, an entrepreneur at heart, sees an opportunity. She offers to partner with Daedalus and turn his invention into a profitable business. She'll front some initial cash and materials, talk to everyone who wants a power hammer, get them on a waiting list, and set Daedalus up with some apprentices that can help him produce the machines. Daedalus says he doesn't want to haggle with a bunch of people for different wages. Electra says not to worry. She'll pay competitive rates and hire a small team to track finances, coordinate payroll, log paid time off and sick leave, secure medical coverage, and any other benefits that will help the apprentices do their best work and thrive in their life beyond work. Daedalus is impressed with Electra's forethought in considering the welfare of their team. He agrees to partner with her, and within no time they've got a commercial machining operation underway called D&E Hammers. Electra has also got big dreams of expanding D&E Hammers beyond Athens to provide tools for blacksmiths all across Greece. D&E is a big success. They're able to sell several power hammers a month and have created a new fixture of the economy in Athens. But over time, a few cracks begin to show. Electra thinks of herself as the boss, but Daedalus feels like he should really be the one making decisions since he knows the technical details of their machines better than anyone. A few of the local blacksmiths have come to Daedalus with feedback about the machines, and he very carefully explained why he built certain aspects of the machine the way he did. The blacksmiths left feeling a bit unheard. Electra has been talking to blacksmiths in Sparta in her efforts to expand the business. She keeps using the company's standard sales pitch about how fast a sword can be made, but the Spartans seem to roll their eyes whenever she mentions it. She promised the blacksmiths in Sparta that D&E can get them 20 power hammers before the end of the month, only to learn that Daedalus and the apprentices think that that's impossible. Daedalus begins to describe the difference between the tensile strength and yield strength of steel, and Electra starts pulling her hair out, uninterested and unable to follow the physics and chemistry at play. The debates over what is most important and what the company-wide goals should be seem to have no clear resolution. Everyone is worried that D&E might fall apart as a business, and everything they've worked so hard for won't be able to continue. One sunny afternoon, an apprentice engineer named Fibonacci approaches Electra. "May I make a suggestion?" he asks. Electra says, yes, of course, my door is always open. Fibonacci has been talking with Daedalus and the other apprentices and translates for Electra. The reason that Daedalus brought up yield strength is because it's the primary challenge with one of the gears in the machine. The engineers think they have a solution that will make the product better and faster to assemble. They want to take an extra month to get the details right, but it means that they would be able to get 50 machines to Sparta the following month instead of 20. Fibonacci also spent some time in Sparta during the summer and learned that the biggest pain point for blacksmiths there is not related to swords. In their culture, swords are often passed down from parent to child, and blacksmiths have recently been able to get more reliable business from forging shields. Fibonacci hands over a 50-page folio that includes research on power hammer manufacturing practices in Anatolia, a proposed strategy for interchangeable parts that would allow D&E to partner with mining companies even if they have existing loyalties to other engineers, and a list of 400 tasks that he can think of that should be assigned and followed up on throughout the next phase of the project. After flipping through the pages of the folio with deep intent, Electra agrees to this plan. Fibonacci begins gathering everyone together for weekly meetings where they check in about anything that's blocking their progress. He starts one-on-one interviews with a few of the blacksmiths who have used their product, carefully noting down their feedback and looking across multiple user interviews for common themes. He prioritizes the engineering task list and makes it available to everyone, responding to questions as they arise and reprioritizing when new information comes to light. As you've probably guessed, Fibonacci is a product manager. Daedalus represents the technological side of the equation, focused on engineering goals and constraints. In a modern technology company, Daedalus and his apprentices would be focused on front-end and back-end software development, DevOps, infrastructure, automated and manual testing, and so on. Electra represents the business angle on the work that needs to be done. She and her direct team are thinking about finance, operations, business development, advertising, and so on. The other blacksmiths in their guild are the users. They're the customers who interact with the product. The goal is to provide them with an unbeatable experience. They have valuable feedback to share if there is someone to listen. Fibonacci, as the product manager, sits at the center between these three cohorts, balancing their competing priorities and using his skill at context switching to translate the differing jargon and help everyone better understand each other. By listening to users, a product manager learns what the biggest pain points are. By sharing feedback with the engineers and listening to them in turn, he learns ways that they might address those pain points with technological solutions. By listening to the business side, he understands the finance-related vision and why certain timelines and milestones might be necessary. By amplifying the greatest strengths of these three perspectives and prioritizing based on their interlinked goals, a product manager can be the crucial ingredient that turns a good product into a great product. Product people are not specialists in one particular area. They're generalists with fluency in a multitude of disciplines. A working knowledge of research and data analysis is essential in order to identify meaningful patterns from user behavior. A basic comprehension of finance and marketing, along with a strong foundation of project management, is necessary to understand the business vision and keep things on track. And while it's possible to be a non-technical product manager, and you don't necessarily need to learn too much computer science, the better you understand the technology that runs the entire experience for the user, the better you will be at understanding the full potential of the product you are stewarding. Product managers build consensus and help unify disparate parts of a company or organization. As a key decision maker for what ends up being built, product managers take on the responsibility for the ultimate success or failure of the products that they oversee. By now, you have a bit more of a sense for how product work fits into any company or organization, so let's take a look at some specific product management frameworks and how they might inspire some of the process behind your daily work. I'm going to take a moment to sip some water. All right. Product management frameworks. The first thing you need to know about product management methodology is no process is sacred. Product management is about getting something out the door so that people can use it and tell you how to make it better. Whatever process or lack thereof that gets you there is the right one. Don't be afraid to experiment, to read Wikipedia pages about concepts that are new to you, to let AI write a first draft for you, to change platforms when the existing system is slowing you down. The sooner you get your product out to people, the sooner you'll understand their needs and how to serve them more effectively. Or as the teams at Spotify put it, think it, build it, ship it, tweak it. But we're getting ahead of ourselves, at least chronologically. All these ideas can be traced back to lean methodology. In the aftermath of World War II, Japan faced serious economic challenges, particularly due to a scarcity of resources like steel. It was in this context that Taiichi Ono, a seasoned loom machinist, joined the car company Toyota, and in 1956 embarked on a transformative reconnaissance journey to the United States. He visited a Ford plant in Michigan and was impressed by the scale of production, yet he knew their methods couldn't be transferred directly to Toyota's assembly line. Toyota simply couldn't afford to have giant warehouses filled with parts ready to be assembled. While he pondered how best to export American manufacturing techniques back home to Japan, he was struck by inspiration in an unexpected locale, a Piggly Wiggly supermarket. Here, Ono observed the efficient replenishment of stock based on demand, an insight that led him to pioneering the just-in-time system at Toyota. The idea of this approach was to finish manufacturing the necessary parts just in time for them to be used in the next phase of the assembly line. Centered around Kaizen, a culture of continuous improvement, Ono formalized the company's methodology in the Toyota Production System, or TPS. TPS served as the foundation for what would later be called lean manufacturing. And this method has a clear and simple goal: minimize waste and maximize value. One example highlights the extent to which this philosophy impacted the company's culture. At Toyota, any worker who noticed a problem could pull a cord to stop the entire production line. In these moments, the entire team would assess any mistakes and adjust their work to avoid repeating them, thereby drastically reducing future errors and improving quality. Ono also developed Kanban, a board of cards that allowed workers to track available inventory and visualize overall progress in the manufacturing chain. In contemporary tech companies, Kanban boards are often made with columns of Post-it notes as a way to enumerate and prioritize opportunities to improve the user experience. Many online project management platforms today have Kanban as a central method of organizing tasks and assigning work. Ono's process innovations allowed Toyota to assemble a car in half the time of their competitors, while maintaining a quality product. In 1972, they leapfrogged their competitors and became the first company to ever cross the threshold of manufacturing over 10 million vehicles per year. In 1993, Boeing deeply integrated lean methodology into their manufacturing process, and Intel did the same in 2005. In 2011, Eric Ries went on to popularize the concept of the lean startup in Silicon Valley. One core aspect of contemporary lean methodology is the concept of a minimum viable product, or MVP. This idea was introduced in 2001 by Frank Robinson, who defined it as that unique product that maximizes return on risk for both the vendor and the customer. Robinson was inspired by Stanford University professor William F. Sharpe, who won the Nobel Prize in Economics in 1990 when he proposed the Sharpe ratio, a calculation of return on investment, or ROI, versus risk. As Robinson puts it, the MVP is the right-sized product for your company and your customer. It is big enough to cause adoption, satisfaction, and sales, but not so big as to be bloated and risky. Technically, it is the product with maximum ROI divided by risk. The MVP is determined by revenue weighting major features across your most relevant customers, not aggregating all requests for all features from all customers. Steve Blank independently outlined a similar concept as part of his customer development method. One approach to defining the minimum features set is to ask, what is the smallest or least complicated problem the customer will pay us to solve? and Eric Ries expanded on Blanks and Robinson's definitions. The lesson of the MVP is that any additional work beyond what was required to start learning is waste, no matter how important it might have seemed at the time. In all cases, the primary goal in creating an MVP is to learn as early as possible from the people who will use your product by putting something in front of them and seeing what they do with it. But where do we start? How do we come up with the first set of features that will be most essential to our users? One way to generate a compelling list of initial features is the Jobs to be Done framework. This methodology came out of a collaboration between Anthony Olwick and Clayton Christensen at Harvard Business School. In Jobs to be Done, the product is envisioned to be a kind of employee of the customer. The goal then is to understand the underlying reasons why customers hire a product or service to accomplish a specific task or job. A customer might hire your product for functional reasons, like landscaping with a lawnmower, emotional reasons, like a particular brand of lock making you feel secure, or social reasons, like wearing fashionable clothing to gain social status. In this way, the features of the product only matter insomuch as they get the job done. By understanding why a customer needs these tasks accomplished, we learn what to build. Jobs to be Done is a way of reframing the product development process to be more customer-centric and outcome-driven. And this is an important distinction: outcomes, not output. Many of our checklist-style ways of creating features are great at tracking the engineering team's output, but we don't want to get lured into the illusion that a big green list of features that are done means we're doing good work. It really doesn't matter how many widgets you added to your product if it isn't meeting the needs of the community you're serving. Outcomes are the central focus of the Objectives and Key Results framework, which Andy Grove invented at Intel in the 1970s. OKRs are deceptively simple. First, you define an objective. What impact do you want a certain product or feature to have? In narrative form, how do you think it will improve the lives of your users? Then key results are the way that you plan to measure progress toward that objective. As an example, you might have an objective to improve the quality of content recommendations in your application. One key result then might be an increase in the conversion rate of people selecting one of the recommendations, let's say from 5% to 10%. You typically want 1 to 3 OKRs per team, such that everyone on the team has a clear understanding of what you're building towards. If you have 10 or 20 OKRs, your work is going to be unfocused and you probably won't move the needle on any of your objectives to the degree that you want. The KRs in OKRs are exactly the same as KPIs, key performance indicators. It's just another term that is a shorthand for measurable data that can tell you if you're on the right track. However, the OKR system has a few differences from the isolated term KPI. Firstly, since there's a plain language objective stated, it's easier to notice when the key results that you've set don't turn out to be meaningful. If they're not accurately describing how well you're achieving your objective, you can change the way you're measuring success while keeping the definition of success, or the objective, the same. Let's use the example objective stated above: improve the quality of content recommendations. Perhaps you made the recommendations more visually appealing, adding an eye-catching image for each recommendation and a satisfying tap interaction after one is selected, complete with sparkling animations and haptic feedback, which is a fancy word for a phone vibration pattern. You might very well discover that the conversion rate of people tapping on a recommendation, which is the key result we set, is indeed going up. But you also notice that time spent in-app is decreasing and your user retention rate is plummeting. This would point to a mistaken understanding of the value of that first selection interaction. We're making it more likely that users choose something, but then once they do, it's not necessarily the right something. A better key result then might be increase the percentage of users who reached a certain completion point in the recommended content. Maybe currently only 20% of users engage with more than half of the recommended content item, and we want to bring that up to 30%. An even more meaningful key result, though perhaps harder to achieve, could be increasing the percentage of users who share the content with someone else. This would imply that not only did we nail it on the recommendation for that one person, but they liked it so much that they wanted to share it with their friends. We could even keep both key results nested under the same objective. Though here, again, we don't want to more than 3 key results per objective, lest we start trying to make that objective accomplish too many things to be meaningful as a North Star. Another difference between OKRs and KPIs is a KPI exists in isolation, while OKRs exist within the context of an entire organization's goals. Your specific team might have one OKR you're responsible for, while another team is focused on a different objective. But both of these would roll up to the same company-wide OKRs, and in this way, OKRs can be a framework for organizing the work of an entire company across all its teams. So, there are countless different product management frameworks, whether it's lean, jobs to be done, OKRs, or some other system. All these processes have the goal of building better products faster. If you find another way to achieve that, then you can throw this list out the window. So again, I'll reiterate the key lesson: no process is sacred. Still, it's helpful to have a toolkit of methods that have worked for some of the most successful companies in the world. These are all terms you're likely to come across in the workplace, and the more that you can experience the pros and cons of different approaches, the more you'll be able to hone your own style of product leadership. All right, I'm going to pause there in case folks have any questions. Yeah, I guess I'll leave a little bit of space here if you want to drop any questions in the chat. But otherwise, I can pick up and continue going through it. Kate, I did create some of the images for the slides with ChatGPT, but the content itself is me writing everything one word at a time. So I'm not sure if that was what your comment was about, but yeah, it's all me behind the scenes. Cool. Well, let's pick it up from here. Keep putting in questions in the chat if you have any of them. And let's get practical. All right, so we talked about kind of what product management is more broadly and how it fits within the work of an organization. But in addition to any fancy frameworks that you'll learn, the nuts and bolts of product work involve a few practical daily activities. You're going to listen to people. You're going to organize feedback. You're going to prioritize what work gets done. And you're going to write specs. So let's tackle each of these one by one and make sure you've got the basic skills needed as a product manager. So number 1, listen to people. As a product manager, a lot of your time will be spent talking to other people to understand the many perspectives on what should be built. More specifically, you won't usually be talking, you'll be listening. You'll listen to stakeholders with different functions at your organization: sales, marketing, editorial, social media management, operations, and so on. You'll listen to engineers who will write the code that makes the products a reality. Most importantly, you'll listen to the people who use your products. Active listening is an entire field of study on its own. You'll hone your craft over time, but you can keep a few things in mind to help you with this. Number 1, seek to understand before being understood. In general, go into every conversation with curiosity, setting aside your preconceived notions to learn more about the other person's perspective. This will help you align your vision with their needs and help you both build a great product that works for everyone. Number 2, be a partner in problem solving. In addition to empathizing with the person you're talking to, really walk alongside them and think about how you can support their goals. You can't solve everybody's problems, but to fully understand someone's pain points, you need to let go of any hierarchies and troubleshoot side by side with them. Number 3, prep for meetings. This is a big one and like a pet peeve of mine. You want to gather notes, data, and any background information that will help you have a productive conversation. When you send a meeting invite, make a clear agenda for what you're hoping to get out of the discussion and ask if there's anything else that should be added. And lastly, you want to follow up. So after a meeting, summarize action items, send out a brief summary, take notes on the things that are of most importance to that person, and make sure to give them an update as progress is made. These principles apply no matter who you're talking to, whether it's stakeholders, engineers, or users. A few things to focus on for each of these different cohorts. Stakeholders. Your primary goal here is to build consensus. This doesn't mean that everyone gets their way. In fact, one of the most important things you can say as a product manager, politely, is no. However, other stakeholders within your organization are usually subject matter experts of one form or another. The more that you understand the evidence that is driving their preferences, the more you can use that to inform what you build in a way that leads to the best product. So with engineers, your primary goal is to understand the technical possibilities and limitations of what you're trying to build. Don't try to force something that doesn't make any practical sense. Engineers are your partners in making sure that you're building within the realm of what's possible. When your code infrastructure is built in an optimized and sustainable way, you can deliver a smooth and reliable experience for your users. Speaking of users, your primary goal with them is to understand their lived experience. Regardless of business goals or quarterly earnings calls or the opinions of your CEO, at the end of the day, the user is the expert of their own experience. Rather than broad or generic discussion points, ask users specific questions that get them talking about a particular moment in their lives. Hearing this narrative will teach you more than you can imagine. All right, so that's listening to people, but you also want to organize feedback. Feedback is going to come in through a number of pathways. First and foremost, all of the conversations we were just describing, which you'll be having just about every day. Those will lead to clear opinions on how things might be built. In addition, questions and feedback will come in through your support portal. You'll notice significant changes in metrics you're tracking that imply enhancements are needed in particular features. You'll do market research on similar products, giving you new insight on approaches that might be successful. If your company is large enough, you'll want a moderated community forum of some kind where your users can start discussions and upvote features. Given how many sources can bring in the best ideas, you'll want some regular practices for organizing this feedback. And here are a few approaches. Write it all down, but don't be afraid to delete. You will always get more feature requests than you have time to build solutions for. So use your best judgment about what to document, but make sure not to lose track of any ideas that are super great. Whether it's a Google Doc, a Kanban board, or a pocket journal, try and keep your own scratch list of ideas you want to follow up on in priority order with the most important ideas at the top. If it becomes clear that something in the list is a won't do, delete it. Follow up with the necessary stakeholders to communicate fully, but if it's truly a needed enhancement, it will resurface from another source in the future. Schedule time to review feedback. So if you don't put time aside on your calendar, it's really easy for feedback documentation to become chaotic or less useful. Never forget that feedback is your most valuable clue as to what will be a meaningful improvement to build. While some ideas will be filtered out as cruft, make sure you spend time to sift through and keep the most precious gems. You want to organize by theme. Once you've got a lot of ideas documented, group similar ones next to each other based on theme or kind of category. Look for patterns. You might notice someone requesting a chat feature, another person asking for a way to contact people, somebody talking about comments, and someone else describing a forum feature. Grouping these together, you may find that actually one solution addresses the underlying need shared between all of them. And lastly, you want to tag and label. So slightly different from the thematic organization, it's likely you'll find that certain feedback fits into multiple categories. Adding multiple tags or labels based on user type, feature, user journey milestone, or any other relevant dimension will help you to quickly rearrange things as needed and understand common issues. You may also want to make notes about who would be excited to hear if this feedback was addressed with a product enhancement. That kind of follow-up builds a lot of trust and brings people back in who may have drifted away from using your product. And then you got to focus and prioritize. So this is number 3 of 4 primary activities of a product manager. Even amongst the gems that drift to the top when sifting through feedback, you still don't want to pursue every good idea. The engineering backlog, which is the prioritized list of work that is fully spec'd, assigned, and ready to be built, should be separate from the product backlog, the list of ideas you're considering pursuing based on aggregated feedback. The product backlog moves from research and ideation to experimentation to specifications. The engineering backlog moves from specifications to code to features on your production environment. Perfect is a distant star. Even if you had all the time in the world, new enhancements would inevitably break some existing feature, and it would be very difficult to ever run out of ways to improve a product. And we don't have all the time in the world. So, one of the most challenging lessons I learned in life was that you can't do everything. There is always more work to do, more ideas to pursue, more people to get back to than you have capacity for. I could respond to emails all day, but I would be ignoring my team and my role as an individual contributor. In my personal life, I could do chores all day, but then where's the time for art and friends and family? You can rearrange the variables in any dimension you want. If you're doing meaningful work, the work is never done. Especially if you work at a startup or you're starting your own business, your runway of upfront cash needs to be put to good use right away and lead to the best returns possible so that you can keep doing great work. This means we need to make the most of the time we have by building the right things first. The things that get sorted to the top of our list of features to spec or the tickets in the top of the backlog will be the ones that actually get done. The things at the bottom of the list are likely to never get done. So, how do we know what to work on first? First things first, focus. Focus is a lifelong practice, but a few methods can help you get further down this path. So, number 1, breathe. Breathe deep into your belly, in and out of your nose. You can also meditate. As the Chan teacher Wu Jing said, just sit. So meditation might seem like a really complex thing, but it doesn't have to be anything fancy. Just take a few minutes out of your day to sit and let your thoughts quiet down a bit. And then music is amazing. I love music. Find some tunes without words that you enjoy, classical, lo-fi, bluegrass instrumentals, whatever works. This will help you get into a focused flow state. Now, prioritization will always be a bit more alchemy than science, but my rough heuristic is effort versus impact. Engineers can help estimate effort in dev hours, and there are many ways to measure impact. You generally want to link the impact to your objectives and key results. Something that's expected to convert many people on your most important metrics will have a high impact. So low effort, high impact tasks are a no-brainer to put at the top of the list. And high effort, low impact tasks should probably atrophy out of the list entirely. Most tasks land somewhere in the middle, but thinking through this ratio will make the order of operations much clearer. All right, the fourth of the 4 primary activities you'll spend your days on as a product manager, you're going to write specs. So once you've got a clear sense of what you want to work on, it's time to explain each specific enhancement so that one by one they can be built by the engineering team. Spec is short for product specification. As a product person, a lot of your day-to-day work will be spent writing specs. These are the instructions that the engineering team uses as the criteria for what to build. A specification is specific. You want to answer as many questions upfront as possible before programming begins. That way, whoever ends up coding the feature can get into a flow state of problem solving and doesn't get blocked from being able to finish the feature. In 2002, a UK-based agile coach named Rachel Davies formulated a structure for user stories that will help guide us when beginning to write a spec. The template is this. As a role, I want action so that value or justification. The beauty of writing in this user story format is that we focus on the experience of the actual human beings we're building products for. That may seem simple, but the language we use profoundly impacts our thinking. Not only that, we're focused on the action the person is trying to complete. So rather than getting stuck on a specific implementation for how to complete that action, we're going to focus on what they're actually trying to do and what the value is they're going to get out of it. While a spec should be specific, we shouldn't be so specific that we're forcing the engineers to use like certain code libraries, for instance. If we use our blacksmith guild example, a user story might be, as a blacksmith, I want to hammer more powerfully for longer so that I can complete my work more effectively without hurting my arm. The power hammer that Daedalus invented would be one solution for this user story. However, we're focused on outcomes rather than solutions, so if it turns out that the power hammer doesn't solve the blacksmith's problem, we may need to change direction with the product. If we were to write a user story for a chef within a family, it might be something like, as a cook, I want to be able to quickly create grocery lists from my saved recipes so that I can make shopping easier and focus on the actual cooking. This user story pairs with a feature you might build for an app like Paprika, if you've ever used that one before. I'm going to take a sip of water. All right, so let's pause a bit to clarify some of the nomenclature here. An opportunity is a user need that is not being adequately addressed. In other words, the possibility to make a difference in someone's life, either by enhancing someone's experience or relieving their frustration. Speaking of frustration, a pain point is that aggravating thing for the user. It's a frustration or inefficiency that's communicated by the user. Similarly, a problem is a frustration or inefficiency that may be identified with or without direct communication with a user. In other words, an opportunity viewed only from the negative perspective. A solution is a specific way of addressing an opportunity, problem, or pain point, not necessarily the right one. There are lots of solutions. We often kind of get stuck on a particular solution, but it's important to remember there are lots of possibilities there. A user story is a plain language description of a pain point you're hoping to address through features in your product. A feature is a coherent unit of software that performs a specific function. A bug is an issue in a piece of software, something broken that needs fixing. A chore is a task that needs to be completed as part of regular maintenance or upkeep on an application or system. Ticket is kind of a generic term that people will often use to refer to the document or item in a project management platform that refers to a specific feature, bug, or chore. Synonyms for ticket include task, which is what they use in Notion, Asana, Wrike, and ClickUp. Story, which is what they use in Jira and Pivotal Tracker. A card, which is what they use in Trello, or the Kanban view for many platforms. A to-do, which is what they use, refer to things as in Basecamp, or a feature, which is what they call it in Product Board. And then the backlog is a list of tickets sorted in priority order with the most important ones at the top. It can also be thought of as a to-do list. When I'm writing the titles of tickets for the engineering backlog, I focus on a simplified version of user story formatting. Role, can, action. While the justification portion of a user story is important context that you might include in the description of a ticket in the backlog, it doesn't need to be in the ticket title. For instance, after initially brainstorming the Paprika example for somebody who's like a chef at home, it would probably split into many tickets in the backlog, including user viewing ingredients for a recipe can tap create grocery list. User can view grocery list screen. User can add an item to a grocery list. User can remove an item from grocery list. And user can edit item quantity in grocery list. A feature and the ticket describing it should be the most atomic unit possible. A feature does one thing. So if you find yourself explaining 5 different pages with different functions, you're probably writing a spec that will need to be atomized and split out into separate stories. One way I like to think about a spec is as a text-based choose-your-own adventure. Each screen of an app or website is like a room the user is exploring. Every interactive element is like an object in the room. So if you only had words to describe a room, but you wanted the user to be aware of everything they can do there, you'd need to describe each object and its function. So too with spec writing. The function of each element needs to be clearly explained, and each function should be considered a separate feature. So let's take one of these tickets as an example. User can add an item to grocery list. The spec I'd write for this story might go something like this. From the grocery list screen, I see a field at the top with placeholder text for add item. Tapping into this field allows me to type text into it, displaying a cursor. I also see a new CTA for done to the right of the text field. As I type, I see suggested items listed based on the text I've entered, and an X icon appears on the right side of the interior of the text field. Tapping one of the suggested items places that text in the text field. Tapping the X icon on the right side of the field clears all text in the field. Above my keyboard, I see numerical values and fractions that allow me to easily set the quantity for an item without needing to switch to the numerical keyboard. If I tap Done, the item is added to my grocery list in the appropriate category, scrolling me down to that section. A brief light blue flash indicates the item was added. If the text I entered is not in the structured data system, it is added to the miscellaneous category, and if I tap Done with no text entered, it simply closes the keyboard and removes the focus from the field. So, as you can see, a good spec gets pretty specific. All of these details impact the user experience and the ease with which someone will use your product. If you ignore the details, you run the risk of building a clunky user experience that makes people want to leave your product immediately. A smooth and enjoyable user experience, on the other hand, will bring people back for more again and again. If you talk to people, gather and organize the feedback you get, prioritize what to work on, and clearly spec how to build it, you'll be doing 80% or more of the work of a great product manager. All right, so that's the end of chapter 2. I'm going to pause here again for any questions if people have them. I'm going to take a sip of tea. Thank you so much, everybody, for joining. It's amazing to see all the folks who are here. I know there are some familiar faces and also some new friends to be made here. So definitely keep the discussion going in the chat. Ask questions as I go through different sections. And yeah, we can get into this next section, which is going to be basically an hour long, but I'll kind of pause in strategic parts to talk about each of the different topics and answer any questions you might have. Okay, so chapter 3, an intro to everything else. Let's start with, kind of what we're going to talk about in this chapter. We're going to talk about code, design, UX design as distinct from design, user experience, and then data analysis and project management. So again, this is going to be an hour-long chapter, but it's broken up into 5 kind of simple sections, and I'll pause a little bit after each section to answer questions. For anyone who works in tech, it's important to have a basic understanding of how the technology itself actually works. So what the heck is code? You don't need to study computer science in order to be a product manager, but it behooves us to have a working knowledge of what code is and why it's important. By understanding the basics behind the tech, we can envision solutions that are practical given the constraints of different frameworks and system architectures. At a basic level, a programming language is a way to deliver instructions to a machine. The people who write these instructions go by many names. Coders works informally. Programmers is a bit outdated at this point. Software developers is one of the more common ways to refer to the official title for this role, though within everyday conversation it's often shortened to developers or even just devs, or dev if you're referring to kind of the whole department. And then software engineers, often shortened to just engineers, usually references a more established coder with a strong background in computer science. They're truly engineering a solution, usually across multiple programming languages and platforms, by thinking of the tech stack as a single interconnected system. The story of how code works is all about abstraction, turning something without inherent meaning into something practical and helpful in our lives. Abstraction changes incomprehensible machine processes into something that humans can understand. As technologists, it's our work to facilitate that change, to transform a perplexing number of complications into user interfaces that seem simple and delightful. At the most fundamental level, code is just a sequence of on and off switches, signals running through hardware. One level up from that, we get binary code, ones and zeros, where we use those on-off signals to have particular meanings and logical outcomes. In mathematics, a system with 2 digits used to represent numbers is called base 2. Everything in computer systems is built on powers of 2. We tend to skip over quaternary code, which is 2 to the second, or base 4, as impractical. 2 to the third is 8, and with a base 8 system, we get octal code, used in Unix systems, among others. Octal representations of numbers are effectively a shorthand of binary numbers, requiring fewer digits to represent the same number. One level up from octal, we get 2 to the 4, or base 16, also known as hexadecimal. With hexadecimal, we can represent binary in even fewer digits, increasing the ease with which we can communicate complex ideas. We can use hexadecimal to represent every character in ASCII, or ASCII, the American Standard Code for Information Interchange. This code gives us 128 alphabetic, numeric, and special characters. You might notice that 128 is 2 to the power of 7. By abstracting meaning out of simple electrical signals, we've gotten to a level where we can now represent recognizable English words. Excuse me. A level or two up from here, we can start turning these words into strings of logic. We get to machine code, then assembly language, then compiled programming languages like C, then operating systems that are written in those compiled programming languages, then applications that are written for those operating systems. And this is the level we're used to interacting with every day. One such application is a web browser, which can navigate us to web applications, built-in programming languages like JavaScript and Python. Usually those languages are implemented in specific frameworks like React, Angular, and Svelte for JavaScript, or Django, Flask, and Pyramid for Python. Then the user interface determines which toggles and buttons and swipe interactions we respond to. There's a massive amount of complexity going on at the level of binary code, and each level up from there is an abstraction that serves to make the human-computer interaction easier to comprehend. By the time we get to consumer-facing products, the interaction should be entirely seamless. Simple products can now be built with no code at all. A content management system, or CMS, colloquially known as a website builder, lets people use pre-made interfaces to publish content online. WordPress, Squarespace, Wix, Ghost, those are a few examples. And then platforms like Glide, Bubble, and Builder let people build more complex web applications. Adalo, Softer, and Flutterflow let people build native applications for iOS and Android. But once you get into a certain level of complexity, you need someone who can write code. No-code applications are a great way to prototype or get an initial startup off the ground, but any major tech company is going to be building custom solutions in most cases rather than relying on pre-built platforms. As a product manager, that means you want to have a basic understanding of logic and maybe even bits of programming language or two. Otherwise, you'll be delegating crucial decisions about how your product operates to someone else who may not have the whole picture. If software development interests you, I highly recommend exploring Code Academy, Crash Course Computer Science, Harvard CS50. These are all platforms out there that have free versions of ways to learn online courses and learn more about computer science. All right. Thank you so much, Connie. I'm glad you enjoyed the class. And yeah, let's keep going. What the heck is design? All technology is mediated through a user interface, or UI. This is the mechanism by which a human being interacts with a digital device or software application. Historically, UI design has focused on all the fields, buttons, icons, and other visual elements that appear on your phone. What the heck is design? Let's start that over. What the heck is design? All technology is mediated through a user interface, or UI. This is the mechanism by which a human being interacts with a digital device or software application. Historically, UI design has focused on all the fields, buttons, icons, and other visual elements that appear on your phone, computer, gaming device, etc. As applications evolve to include text-to-speech and AI prompts, conversational interfaces are another key element that needs thoughtful design, but more on that in the next lesson. For the purposes of this lesson, we'll focus on the visual aspects of design. The folks at IA.net describe the discipline of design as learning to see. By observing great examples of design with your own eyes, attempting to duplicate them with your own hand, you will feel, see, and eventually understand the invisible lines behind a great product at a deeper and deeper level. Our perceptions of the world around us deeply influence what we expect from technology and how we interact with it. John Berger describes it this way in the 1972 BBC documentary series, Ways of Seeing. The process of seeing paintings or seeing anything else is less spontaneous and natural than we tend to believe. A large part of seeing depends upon habit and convention. Certain psychological concepts play a crucial role in how we perceive user interfaces, and the most famous of these are the Gestalt principles of perception, which describe our brain's innate ability to categorize and tell a story about what we see and what we don't see. So I'll just go through a few of these principles here. Continuity is the tendency for our eyes to follow the smoothest path when viewing lines, even if that line is interrupted or there is other noise in the frame. So for the Plant Chicago logo, you can see there are actually little gaps in between these lines. There's like dashes and white space there, but our brain perceives this as a kind of continuous string and almost makes those white spaces into a sense of depth perception. So I think it's a beautiful logo and a cool use of continuity. Closure is the principle that describes how our brain fills in negative space to complete a picture, even if lines or other elements are missing. So in the World Wildlife Fund logo, you can see that the top of the panda's head, there's not actually a line there that completes the shape of the head. Our eyes are filling in that white space. So even though there is negative space there, we want it to feel closed, and so we kind of finish the picture with our minds. Proximity is the way that we interpret the closeness or distance between objects as a way of mental grouping. So in this Cancer Research UK logo, on the left you just have a bunch of dots, but as they kind of become more and more close to each other, more and more proximal to each other, the image of a C becomes clear, even though it's really just made out of many dots that are close to each other. And then figure ground allows for two different pictures to form a single set of lines and shapes. The classic vases face example is the best known demonstration of this principle, and then you can see the mentoring project uses that same idea where the large elephant is kind of the positive image, and then the negative space inside or below and inside of that larger elephant creates the image of a smaller elephant. I think it's a really, really cool logo and a really cool use of figure ground. And so on. So similarly, the use of particular colors brings out primal feelings that guide how we interpret a UI. We're calmed by blue colors that remind us of water, warned by reds that remind us of blood, and encouraged by greens that remind us of healthy plant life. In addition to psychological factors, our cultural context influences what we expect from a UI, whether from nature, industrial design, interior design, or architecture. The world that surrounds us is filled with familiar shapes, textures, and imagery that come to signify meaning. After the command line, the earliest graphical user interfaces, or GUIs, had low pixel density, so design had to work with a limited amount of nuance to make elements familiar. While working at Apple, Susan Kare left a major imprint on digital design when she introduced the bitmap icons for the first Macintosh operating system in 1984. She was the first to use a trash can icon to signify deletion. Several applications still use the image of a 3.5-inch floppy disk to signify a save action, even though this file storage method is entirely obsolete. She decided that the image of a Mac computer that displayed while the machine booted up would be smiling at you. And after a bit more pixel density was available, toggles, buttons, and dials usually had a skeuomorphic aesthetic. That is, UI elements in 1995, for example, often looked like objects in the real world, complete with gradients, forced perspective, and other 3D effects. So in this example, the White House website had a placard at the top that looked like a real placard and a gradient and a background. The guest book is a picture of an actual guest book. Intel's website from the 90s had an actual image of a computer that served as the navigation around the site, and you kind of see the depth perception on the buttons. Those are examples of skeuomorphism. While these same basic shapes have lived on in UI design, skeuomorphism has largely gone out of fashion, perceived as creating a more cluttered or tacky user interface. Around 2012, flat design emerged as the default design approach. Inspired by the Swiss aesthetic established in the international typographic style of the 1950s, flat design fully eliminates 3D elements and lined borders in favor of using the difference and arrangement of color and shape to distinguish distinct elements as interactive. So in this Airbnb example, you see that the Pine Plains, New York listing search result doesn't actually have any kind of card around it or something that's enclosing it. It's not like a button that looks like something you would press. It just is the image and then the text around it. And the kind of principle of grouping things together is what helps you understand the proximity of those elements, helps you understand that it's one clickable result. And then Google shifted flat design to include very subtle skeuomorphic elements in their open source material design system. This approach has largely taken over the UI design of most apps and websites. The basic concept envisions physical pieces of paper stacked on top of each other, and in this way we avoid the tacky feeling of intense 3D shading, but we bring back gradients in the form of subtle drop shadows and layers. So in the case of this audiobook platform, you've got an image that's on top of a gradient, and so it creates this sense of depth perception, even though those are two flat elements kind of in conjunction with each other. And then a lot of the other flat design elements are just the shape itself with icons, just text. It's kind of simple UI elements there. So UI conventions create their own expectations as well. You can return to a 1990s GeoCities brutalist aesthetic, but it will be a striking choice that is surprising for most users, potentially in a negative way. You could imitate an existing popular app almost exactly. This will likely lead to user friendliness on day one, but then you're not differentiating your brand in an interesting way. Whatever style you develop, it should be consistent throughout your application. Most importantly, while you have business goals and although you're working within the constraints of what is possible with code, design is for the user. As Don Norman puts it in The Design of Everyday Things, do not blame people when they fail to use your products properly. Take people's difficulties as signifiers of where the product can be improved. Design has evolved by leaps and bounds since the Macintosh first debuted 40 years ago, yet certain principles and iconography have proved to be enduring. The visual world that we present to our audience is a vocabulary, a personality, a tone. In short, it's a vibe. This is the first impression that we never get a second chance at, so it's important to understand what we're putting out to our community. If you don't currently have a ton of design experience, there are still some steps you can take as a product person to make beautiful content and interface concepts. The first place to start is with pencil and paper. You can draw wireframes on any blank piece of paper, graph paper, or isometric dot matrix. Just start sketching interface layouts. Invent an app in 5 minutes. Play with how the curve of letters in a font can affect readability and emotional character in addition to visual style. Canva, as many of you probably know, is a great tool for starting with very basic manipulation of graphics, especially since it has a thriving community of creators who share templates, many of them freely available. And then Figma gets you just about everything you need from a professional design tool, and especially since it supports a great deal of integration with code, many major tech companies are moving toward Figma as the primary design source of truth. Start in a place that won't overwhelm you and figure the rest out as you go. If design interests you, I highly recommend Hack Design, which is an email course that provides weekly design lessons curated by 65 different professional designers. The Complete Beginner's Guide to Interaction Design, which is a nice online tutorial by UX Booth. Helvetica is a really fun documentary. Everything is a Remix is a cool documentary series that gets you kind of the cultural context for a lot of symbols and representations that we see. And then there's a lot of other options. But I will pause there. This has been about design. We're in chapter 3, which is this hour-long chapter of this introduction to product management. So I want to open for any questions people have. This is the second out of 5 lessons in this chapter. So I'm going to dive into the next lesson, but if you have any questions about design or code, which we just talked about, drop those in the chat. And yeah, I take this as an opportunity to discover interesting people as well. Keep the conversation going in the chat. I'm going to take a sip of water. Okay, so we talked about design. What the heck is UX design? So if we already talked about UI design, why is there a whole other lesson here about UX design? What's the difference? While all designers should be taking the user experience, or UX, into account, it's easy for the visual elements of an interface to take precedence over the full range of behaviors, emotions, and motivations of someone who engages with a product. UI and UX inform each other, but you can be a designer without delving deep into user experience, and you can be a UX designer with minimal visual design chops. Consider the example we mentioned in one of the previous lessons, a conversational interface with an AI agent. In this case, the UI is incredibly minimal. If it's an interaction that happens with voice, the physical device itself is the only visual element. It's that box or speaker or object. That's the only UI that there is, and then the voice interaction. If it's an interaction that happens through typing, you want a good font, you want a chat box, but the majority of the product experience is in the substance of the conversation, which is outside the realm of UI, but firmly in UX territory. The design of a conversational interface has much more to do with whether someone achieves their goals, what their mental state is before and after a conversation, and whether they found enough value to want to come back again in the future. In short, rather than focusing on precise visual aesthetics, the design of a conversational UI has more to do with psychology, ethics, and empathy. To develop this offering effectively, a UX designer will need to work closely with product and engineering to nail the tech behind the dialogue. They'll need to do a great deal of research, information architecture design, user journey mapping, and interviews with users. The end result of the UX design process in this case will focus less on the fonts or the text entry field. The deliverables will likely include reports on what themes were discovered from user interviews and other research. The information architecture and journey mapping will both inform workflow diagrams that explore different scenarios a user is likely to face and how the AI should respond in such scenarios. This will then inform how a product manager makes the final decisions when writing the spec for the rules that guide the conversational interface. Due to the success of ChatGPT and other AI products, conversational UIs are increasingly mainstream, but there's one cohort that's been engaging with them for decades. People with disabilities require an entirely different set of accommodations. For someone who's blind, traditional techniques of UI design are completely irrelevant. Websites with the coolest fonts and hippest colors all end up as a conversational UI, a dialogue facilitated by a screen reader or other assistive technology. In this context, learning to see is a woefully inadequate definition for the discipline of design. Designers must learn to experience. The broader consideration of people who use assistive technology in order to access product experiences is called accessibility. The field of accessibility considers people with disabilities, such as blind and deaf communities. It also considers, among other things, neurodivergence, the social circumstances of different communities, the differential nature of internet access across the country and the world, and the education or reading level of people who may use a product. Accessibility plays a key role in UX research and design. We can continue to illustrate the emphasis behind UX design by deconstructing the concept of a UI even further. In a discussion in Stack Exchange's user experience section, someone asked, "What is the most common user interface in the world?" The question seems innocuous at first until you realize that the questioner hasn't specified any kind of context. Some common software interfaces were put forth. Someone suggested the command line, since it's used to access just about every computer, operating system, or gadget there is. Another user suggested the button and its cousin hyperlink. Then things got interesting. If the word interface is taken to mean any way in which a user interfaces with the world around them, that is, engaging with something for the purpose of performing an action, that significantly broadens the scope of the question. This is closer to the classic design concept of an affordance. The industrial design-minded commenters started thinking outside the box. A toilet, one poster suggested, is the most common user interface. We all use them, and we all have to learn how to use them. A water faucet, a doorknob. And then someone laid down the ace. The only intuitive user interface is the nipple. Everything else is learned. This quote, in different forms, is attributed to many. Bruce Edgar seems to have evolved it from newsgroup conversations somewhere around 1995. Regardless, I love it. It has the profound Zen-like Gordian knot-cutting bite of a Lily Tomlin punchline. In all these examples, it's clear that we're thinking about a broad spectrum of human experiences, regardless of the interface. We can contemplate the experience of someone interacting with a faucet, a doorknob, or a nipple. Countless other elements figure into UX design. Gestural interfaces, haptic feedback, smell cannons at theme parks, these all play a role in fine-tuning a user experience. The human brain, as the place where all of our experiences are interpreted, is another important focus of UX design. An important area of psychology to study up on is that of cognitive biases. Biases arise when we look around us and assume that our interpretation of the world based on past experience is an exact match with how the world really is in any given moment. It's a mode of thinking that Edmund Husserl called the natural attitude, and it is very often successful except when it's not. Our intuition that a red stove coil will be hot before we touch it really helps us to not get burned. But certain other ways of thinking are substantially less connected with what's really going on in the world. Did you know, for instance, that when we talk to someone while drinking warm coffee instead of iced coffee, we're more likely to perceive them as generous and caring? This is an artifact of embodied cognition. Confirmation bias is another common example. We tend to seek out information that confirms our pre-existing beliefs. This has major repercussions for how we organize and emphasize certain information online. In the products we build, are we helping to diversify the perspectives our community is exposed to, or are we isolating them further into bubbles or echo chambers? Connected with confirmation bias is the availability heuristic. which is that we use the examples that come to mind first to try and figure out what is true. This leads us to think that our first idea is the right one, which tends to bias us towards things we've learned more recently, which is called recency bias, or ideas that are dug in from earlier in our lives, which is called belief bias. Not only does every user arrive at a system with preconceived biases, the systems themselves, since they are made by humans, also have biases written into their algorithms and AI training. Whether it's facial recognition tech that often struggles to correctly identify people of color, resume screening tools that recreate gender disparities, or AI that shows extreme racial prejudice in who gets approved for a mortgage, it's essential for UX designers to work to minimize the harmful effects of algorithmic bias. All these considerations and more go into the discipline of UX design and the UX research that supports it. If UX design interests you, I highly recommend Coded Bias, which talks about algorithmic bias that I just discussed. Don't Make Me Think Revisited by Steve Krug. Just Enough Research by Erica Hull. And a bunch more possible resources that I'll include in the description and below. Okay, so that's the third of 5 lessons in this chapter. Again, this is an hour-long chapter, chapter 3 of an introduction to product management. Please let me know if you have any questions about user experience design, or code, or anything else related to product management, and I'll try to respond as best I can. So drop any comments, questions in the chat, and keep the conversation going. And now we'll move on to what the heck is data analysis? I'll take a sip of water. What the heck is data analysis? Data analysis might seem like an intimidating phrase to some, especially if you're a non-technical product manager. However, it's a crucial skill in making strategic decisions. Data, after all, is just a fancy word for evidence, observations, a documented incident of something occurring. I can guarantee that you're actually doing data analysis every day, regardless of your profession. Data analysis is the process of systematically examining structured information to uncover patterns, trends, and insights. When you look at the weather report and see what temperature it is outside, you make a decision about what clothes to wear based on whether it's hot or cold. In this case, temperature arrives as information, a number, but even if you simply open the door and feel the air, you're still collecting data from sensations and interpreting it in a way that influences your decisions. When you're swiping through a dating app, considering whether somebody might be a good partner for you, that's data analysis. When you look at how many people liked your post on social media, data analysis. When you track how many steps you walked in a day, you got it, data analysis. I say all of this to remove some of the mystique from the term, but as you may have guessed, doing data analysis as a product manager usually involves a bit more complexity. It's work, but it's achievable, and you need to be incorporating this skill in order to make evidence-based decisions that accomplish your desired outcomes. So let's take a brief tour through some essential data analysis principles, starting with accuracy and consistency. It may seem straightforward, but if you're analyzing data, you need to make sure that you can trust the source of that data. A brief example can help illustrate. I was working on a project early in my career that involved tracking how many total searches had been performed on our website. I was excited to see a sharp increase in searches over the course of 1 week. They had nearly doubled. I checked the numbers again, and I hadn't made a mistake in my analytical process. I immediately checked the release notes I'd sent at the beginning of the week, looking for what feature or UX adjustment my team had made that might account for the increase. I proudly sent an email reporting the data to all staff as a major win. And luckily, the CEO was thinking critically about my analysis. He responded, just to me, mentioning that the data seemed off. After we checked in with our engineering team and did a bit of digging, we discovered the truth. A bug had been introduced where every time someone ran a single search, 2 analytics events were being triggered. The total number of searches hadn't actually changed in any meaningful way. The analytics data was just inaccurate. Even though it wasn't accurate, the data was technically still consistent. It was very reliably delivering the wrong result. Accuracy is about hitting the target precisely, while consistency is about hitting the same spot right or wrong every time. If, for instance, the analytics events were triggering only 60% of the time, or only on even dates of the calendar, that would be an issue of consistency, requiring different solutions to address. There's a garbage truck outside. Take a sip of tea. In the case of analytics events triggering twice instead of once, we can debug the logic to ensure it goes back to triggering only once. In the case of analytics events triggering 60% of the time, we might need to do a deeper analysis to distinguish the technical differences between people who triggered the event and those who didn't. For instance, maybe the event is only triggering on mobile devices but not on desktop, or it's triggering in Chrome but not in Safari. In this case, the code logic itself might be perfectly sound, but a compatibility issue needs to be resolved. These days, I focus almost exclusively on data points for unique interactions, centering the behavior of the actual human beings that did the thing. If I want to know how many times they did that thing, I'm usually comparing one group's behavior to a different group. Meaning, instead of concluding that people on average run 5 searches on the site, I would examine how perhaps people who sign up run 20% more searches than people who don't. Or maybe even our education articles appear most frequently in search results, but people are more likely to click on a search result related to personal finance. Of course, the principles of accuracy and consistency apply far beyond bugs in site analytics implementation. If you're using survey data, you'll need to make sure you're considering how you're recruiting your participants and whether they represent a diverse sample of the community you're trying to understand. If you're using a high-value reward as an incentive for user interviews, that might make it less likely that people will share critical feedback unless you explicitly state that's the kind of feedback you're looking for, and so on. The lesson here: if your data is giving you a result that's too good to be true, it's entirely possible it just isn't true. As Carl Sagan said, extraordinary claims require extraordinary evidence. In your data analysis, you also want to make sure to ask the right questions. You could spend all day, every day, answering questions that don't really teach you something interesting or new. Don't waste your time like that. For instance, although people have been tracking page views, sessions, and time on site for decades, these ultimately are very weak metrics in isolation. They tell you vaguely about the overall volume of activity on your site, if you effectively exclude all the bots that often show up in the data, but they don't tell you anything about people's behavior. Did people spend a lot of time on your site because they found it to be such a valuable resource, or was it actually because they struggled to navigate and find what they were looking for? Did those page views and sessions convert into purchases or signups, or did they mostly represent people who left dissatisfied and went to a competitor? This takes us back to OKRs, as discussed in Lesson 5. Start with your objective. What is the actual outcome you want to achieve? Until you know this, you won't have any sense of what data is most important. Once you have the objective, you can think of how you would ideally measure it, and the key results become easier to define and track. And these are just a few examples. If your objective is to grow your community, then the key metric should be probably something along the lines of increase user signups. If you want a thriving business, you probably want to increase revenue as the key result. And if you want happy customers, you might want to increase customer satisfaction scores. Excuse me. Okay. Logical reasoning. When interpreting information, our brains have some funny quirks. We often think irrationally or jump to unfounded conclusions. We discussed some cognitive biases when talking about UX design, and these apply to how we analyze data as well. In addition, you'll want to avoid some common logical fallacies that can lead to false information masquerading as insights. A hasty generalization, for instance: don't think that by understanding one thing, you understand everything. Just because your friend told you something about their experience with your app doesn't mean you need to add a change to the top of the backlog. A false dichotomy is, if one explanation is wrong, it doesn't mean the alternative explanation you have in mind is necessarily right. When deciding between option A and option B, don't forget there's usually an option C. Quakers call this a third way. Just because you're deciding between a blue button and a green button doesn't mean that an orange button isn't an option. Correlation is not causation. You may have heard this one before. Two separate metrics might go up or down in the same pattern, but it doesn't necessarily mean that one of them is causing the other one. Only a true experiment can determine causation, and we'll talk about true experiments in a minute. And non sequiturs, or does not follow. Don't jump to conclusions based on weak evidence. Just because people scrolled to a certain part of the page doesn't mean they read the entire page or learned what you were hoping to teach them. Avoiding these and other logical fallacies will ensure that your decisions are founded in solid reasoning. And then here's the piece about true experiments. Independent variables, controls, and randomization is how we get there. Sometimes you'll need to make decisions based on the simple ups and downs of a metric. Even one solid metric, if it's the right one, can give you a lot of great insight. Examining it within the context of a number of complementary data points is even better. And best of all is to perform a true experiment. It's like focusing a lens, unblurring and adding dimension to your perspective, turning up the pixel density on the opportunity you're trying to understand. Let's say you're measuring the conversion rate of a button. On Thursday, the button is blue, and then on Friday morning, you change it to be green for everyone. You measure the conversion rate before and after the change. You might be able to learn something if the change has a big enough effect on people's behavior, but if the behavior change is 1% or even 5%, how do you know it's not just due to random variation or because people are more likely to go on vacation on a Friday? Every once in a while, you have the opportunity to run a true experiment. If you're able to collect data on a high enough volume of interactions, you can begin to think about how you might change one detail and see how people respond to that change. In order to run a proper experiment, you have to have three essential ingredients in place: an independent variable, control variables, and randomization. If you're able to keep everything else as stable as possible, then the one detail you change is called the independent variable. You can then observe the dependent variable, which is the metric you're hoping to change by manipulating the independent variable. With all else equal, if you see a statistically significant change in the dependent variable, you can be certain that it's the independent variable that caused that change. This is the essential component in definitively determining cause and effect relationships. In our example, the color of the button is the independent variable, the thing that we're changing. The dependent variable is conversion rate. We're hoping that button color influences conversion rate, meaning we're guessing that with all else equal, conversion rate is dependent on button color. Control variables are what is implied by with all else equal. The structure you have in place to keep everything else as stable as possible is a system of controls. In our example, the rest of the website is made up of control variables. If we want to test the effect of changing button color, we're not going to also change the call to action text that displays on the button, or add a new animation effect when hovering over the button, or add 2 extra paragraphs that push the button further down the page. And we're not going to compare results from Thursday to results from Friday. If we're hoping to run a true experiment, all variables other than the independent variable need to be controlled for, meaning they stay exactly the same between the two scenarios. You may have heard of A/B testing. This is the industry vocabulary for an experiment that compares two different scenarios. The A variant typically refers to the current design of a product experience before any change is made, and the B variant includes changes that we hope will make an improvement. People who see the A variant are in the A group, which is a control group, and people who see the B variant are in the B group, an experimental group. It's possible for an A/B test to not be a true experiment. For instance, if you split 50% of traffic to one page and then the other 50% to a completely different page with an updated design, you won't know which element of the page is the thing that improved conversions. There's no independent variable and thus no way to determine causality. In fact, you might not care. You're a product manager after all, not a scientist. There may be 40 different variables that changed, all contributing to an improved experience in some small way, and you don't need to test each of them one by one. As long as it converts better, the question of why doesn't necessarily matter, but whenever possible, you want to understand what factors lead to success so that you can incorporate them into your strategy for other areas of the product. In order to ensure the best possible results, you need to incorporate an element of randomization in the experiment in order to get valid, true experimental results. In our experiment with blue and green buttons, if we were to split people into different groups based on gender, for instance, that wouldn't be random. We wouldn't be able to tell if the color of the button was the variable that mattered, or if men just prefer one color, women prefer another, and trans or non-binary folks prefer something else. By randomly assigning participants in the experiment to one group or another, we ensure that both the A group and B group have a diversity of gender, age, race, ethnicity, location, socioeconomic status, and so on. By randomizing, we're lessening the effects of these other variables to truly understand the specific impact of changing button color. Incorporating these and other analytical practices into your work will ensure you're making sound decisions grounded in evidence-based thinking. So that's data analysis in a nutshell, in 15 minutes, as quickly as I can explain it. Yeah, what questions do you all have? Drop them in the chat. I've been excited to, be engaged with all of you. I'm so grateful you're joining for this conversation. This is lesson 4 out of 5 of a 1-hour session that we're going to keep going through. So we talked about code, design, UX design, and now data analysis. So lastly, in this chapter, and lastly, overall, we're going to ask the question, what the heck is project management? What distinguishes project management from product management? Well, project management can be applied across a broader range of activities. You need strong project management skills when building software products, but you also need them when working on a construction site, organizing and scheduling content across different channels, planning a wedding, or filming a movie. You often have a product at the end of that project, but not necessarily. Project management is all about breaking down a large scope of work into smaller tasks, organizing those tasks in a sequence, assigning each of them to the appropriate person, and estimating a date for their completion. It may sound simple enough, but it takes a great deal of forethought, conversation, follow-up, risk mitigation, change management, and so on. It's easy enough to assign one task, but to scope and delegate hundreds of tasks, making sure they're all arranged in the proper order like a Rube Goldberg machine of interconnected deliverables, that takes practice, patience, and perseverance. Since you'll need project management skills as a product manager to make sure things stay on track, here's a bit of a history of different project management frameworks and the lessons that we learned along the way in their creation. So we begin at the dawn of time. Not quite, but ancient project management, just to kind of ground ourselves in like what are different ways people have done this throughout all time. As humans started living in larger groups around 10,000 years ago, there was a need to understand the many moving parts of a project. Pyramids, cathedrals, the Great Wall of China, Göbekli Tepe in Turkey, all of these projects required the coordination of many people and materials. But the planning and implementation methods were often crude and in some cases relied on enslaving or exploiting people to reach project completion. This brute force approach to planning persisted for thousands of years in ancient Egypt, Rome, India, and numerous other civilizations. In the 1800s, the project to build a transcontinental railroad across the United States was the most massive project in scope up to that time. The project was scouted and planned with the best intentions, but still human welfare wasn't really taken into consideration. The workers weren't enslaved, but the work was backbreaking and dangerous. The folks who were working on the project included 10,000 Chinese workers, 8,000 Irish, German, and Italian immigrants, and we know that at least 1,200 Chinese workers died laying track for the Transcontinental Railroad. Through slave revolts, worker revolutions, and protests, most people have now gotten the message that this mode of authoritarianism is a pretty monstrous and ineffective way to run a project. So in the first days of the 20th century, Frederick Taylor, who's not the best guy, but a little better than some of the kind of monstrous folks in the past, Frederick Taylor introduced scientific management. His approach was grounded in the systematic study of workflows, tasks, and the time they took to complete. Often referred to simply as Taylorism, this method was developed based on his experience as a foreman at the Midvale Steel Company. It involved detailed observation and measurement of task performance to identify the most efficient ways to carry out work. Taylor believed that by analyzing work in a scientific manner, it was possible to find the one best way to perform tasks, thereby optimizing productivity. The emphasis was on maximizing efficiency through the meticulous design of work tasks and the selection and training of workers. Henry Gantt, a contemporary of Taylor, extended these principles. He invented what is now known as the Gantt chart, a tool still ubiquitous in project management today. This visual charting technique allows managers to easily see the start, duration, and end of tasks within a project, as well as their sequential relationship to each other. Taylor's and Gantt's methods laid the groundwork for modern project management techniques. Their focus on efficiency, task optimization, and the visual tracking of progress has influenced countless management practices. In 1957, Morgan R. Walker of DuPont and James E. Kelly Jr. of Remington Rand combined forces to develop the critical path method, or CPM. This approach to project management involves identifying the longest sequence of dependent tasks in a project, known as the critical path, to determine the shortest possible project duration. By focusing on these crucial tasks, project managers can allocate resources more efficiently, anticipate potential delays, and prioritize activities that directly impact the project's completion time. CPM has since become a foundational tool widely used in construction, engineering, and software development, among other industries, to optimize project efficiency and effectiveness. And then there's the moonshot, one of the most ambitious projects ever to land astronauts on the surface of the moon. In 1950, George M. Low started work as an aeronautical engineer. He moved up the ranks in DC and then Houston, and in 1961 he wrote a report for NASA that advocated for a lunar landing. President John F. Kennedy read this report, and based on its findings, he decided in 1962 to formally commit the United States to landing Americans on the moon before the end of the decade. In 1967, George Low became the manager of the Apollo Spacecraft Program Office, essentially overseeing all the different elements of the Apollo project. He joined after a tragic fire had taken the lives of the Apollo 1 crew. He dedicated himself wholeheartedly to ensuring that every single aspect of the Apollo program going forward was rigorously tested, that no detail went overlooked. From June 1967 to July 1969, we met 90 times, considered 1,697 changes, and approved 1,341. So that's George Low talking about the Apollo program. He says, "We tore the command module apart, literally all 2 million parts, and then we put it back together the way we wanted it to be." During a 1975 speech at Rensselaer Polytechnic Institute, he said, "I learned how to be inquisitive. I learned to be curious. I learned not to be afraid to ask questions. Once a question is asked, once a problem is identified, a solution can always be found. In space, we are successful because we are curious, because we look for answers. And whenever we did have a failure, the reason was always the same. We had failed to be inquisitive." At the program's peak, NASA employed 400,000 workers as part of the Apollo program. Astronauts, mission controllers, contractors, caterers, engineers, scientists, nurses, doctors, mathematicians, and programmers. One of those programmers was Margaret Hamilton, who famously led the team that wrote the code for the command module and for the lunar module that landed the Apollo 11 astronauts on the moon. You can actually find the full code for the Apollo guidance computer on GitHub, which is kind of fun. Fred H. Martin was the project manager for that coding project. All the work of all the teams was compiled into a 340-page flight plan. All components were tested in and out of context. They did multiple full mission simulations running through the entirety of the flight plan, activating all circuits and switches with the machines still on the ground. And, well, they did it. You know the rest. 3, 2, 1, liftoff. One small step for man, one giant leap for mankind. While every individual specialist played their part, we never would have gotten to the moon without people like George Low and Fred Martin organizing the necessary sequence of tasks, and certainly not during the 1960s. So, the moonshot is kind of one really great example of waterfall methodology. In 1970, Winston W. Royce introduced waterfall methodology, a process in which distinct phases of a project cascade from one to the next with little overlap. The sequence of waterfall project phases are requirements gathering, design, which is both logical and physical, implementation, verification, and maintenance. While this method is pretty outdated, honestly, based on our current way of building tech, it's useful to think of these different components of the work. So the Apollo program is an illustration of a waterfall-style approach in action. Many different teams needed to accomplish their work in a particular sequence, all leading to one definitive and literal launch moment. Excuse me. Before the 80s, waterfall methodology was simply the way technology was built. A team, let's say IBM releasing their first personal computer, the IBM 5150, would set a launch date far into the future. Then they would start work on the entire suite of features, assembling every button, every toggle, and every line of code into a final product. There was no system for continuous software updates like we have now. Even in the 90s, if Mosaic wanted to ship an updated version of Netscape Navigator, they needed to mail a new physical CD-ROM out and encourage people to install it. This practical limitation meant that each individual version had to be a complete, polished product. Rapid iteration on that product after launch just wasn't possible. So project phases almost always cascaded in a waterfall fashion by necessity toward the one singular launch date. But even before CD-ROMs became popular, some innovative thinkers were recognizing the benefits of collaboration across different specializations in a less linear fashion. In 1986, Hirotaka Takeuchi and Ikujiro Nonaka wrote a paper titled The New Product Development Game. They analogized NASA's approach to a relay race, a sequential process where a handoff happens from one group of functional specialists to another in a specific order. In contrast, they argued that the most effective work at companies like Honda and Fuji Xerox was happening in cross-functional teams. They likened this approach to rugby. In these cases, a multidisciplinary team, in their words, quote, tries to go the distance as a unit, passing the ball back and forth in a process of iterative experimentation. They talked about this as moving the scrum downfield. In 1993, Jeff Sutherland adapted this Scrum methodology for software development at Easel Corporation. Since then, it has evolved into a formal process. Planning occurs in a unit of time called a sprint, which can last anywhere from 1 to 4 weeks. And 4 important meetings provide the scaffolding for each sprint. There's sprint planning, in which the priority work is defined and goals are set for what success looks like. There's a daily scrum, which is a 15-minute daily meeting to check in on progress and any challenges that are arising. There's a sprint review, in which stakeholders in non-technical roles join to learn what has been worked on that sprint, and this often happens in a demo setting showcasing features and fixes. And then there's the sprint retrospective, in which the Scrum team discusses what went well and what learnings arose for how to improve in future work. Some contemporary software teams follow this structure almost religiously, while others have adapted it more loosely to fit their own unique needs. In 2001, software experts representing different work methodologies, from Scrum to extreme programming and beyond, got together and wrote the Agile Manifesto. At the core of this philosophy are 4 values: individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. You can see how this is really different from something like waterfall, where everything kind of is locked into a particular plan. Responding to change is more adaptive and more in line with contemporary tech work. As Jim Highsmith describes it, taken as a whole, the practices define a developer community freed from the baggage of Dilbert-esque corporations. The collaborative, self-organizing nature of Agile became the driving force behind startups from the early 2000s onward. And the best thing you can do is integrate these different methodologies. Agile, Scrum, and Lean, described in earlier lessons, all have come to underlie the work at most contemporary tech companies. Each of them can respectively be summarized as: things change, stay human, stay adaptive; working cross-functional teams to help build things a little bit at a time, gathering feedback along the way; and do more with less. There are countless other systems like SWOT analysis, Crystal, Six Sigma, Prince2. There are tons of platforms you can use to track a project. The main takeaway should be no single system will fix all of your problems, and ideally, you should make yourself adaptable to different approaches depending on the context, company culture, and type of project. If project management interests you, I highly recommend exploring How Big Things Get Done by Bent Flyvbjerg. Bent Flyvbjerg and Dan Gardner. Interactive Project Management by Nancy Lyons and Megan Walker. And then the Project Management Institute has a great YouTube channel, and you can find all sorts of other like day in the life of a project manager content out there. So that's project management. And this brings us to the end of today's lessons. Congratulations, you've done it. You completed this introduction to product management. You can now understand what a product manager is and how their work relates to the work at a tech-focused company or organization. You know some key product management frameworks that are used at the most successful tech companies. You've got some practical skills that will help you in your day-to-day work. You've got a basic sense for some of the other disciplines you'll be working with: engineering, design, UX, data analysis, and project management. Now it falls to you to take these lessons and run with them. Work on building a network of other tech professionals who can keep you connected to what's happening in the tech world. Go to meetups, talks, and conferences. Dig deeper into the areas of work that interest you most. And don't forget to have fun. I hope this course gave you a glimpse at the exciting aspects of working as a product person. Until next time, may you find joy, purpose, and play in your world and your work. Thank you everybody for joining. This has been amazing. I have a feedback form, which I would love to kind of gather any thoughts that you have. I'm placing it in the chat now. So please let me know how this went for you. What's exciting to you? What is kind of working best? What needs to be changed? What are all of the ways that I can make this a better online course? Yeah, and then I'm still here if you have any questions to drop them in the chat. I'm very excited to everybody who joined, and I'm so grateful that you're jumping into product management. And yeah, I don't know. Let me know what you think, and I'll go ahead and end the stream here if there are no other questions. Oh, Mizuki, yeah. I'm so glad you enjoyed this. Okay, cool. Yeah, breaking that down into the five major areas was helpful. All right. It's good to hear from you, uh, Mizuki. And yeah, thank you to everybody for joining. I'm just going to cap things off here. This was a great day, and I'm really grateful for you being here. And thank you uh, for all of your attention and your time. See you next time.